Okay, hi everybody. I will try to share my slides because I prepared a huge presentation. I will not use all the slides. I will try to jump to the slides which will be helpful for explanation and better understanding of this topic. But there are two comments before I will start. Just a second. I will try to start this. No, just a second. Give me a sec. I will try to find my, okay. Looks like it's here. Yeah, it's okay.
Yes,
do you see it?
Everything is good. Yeah.
Yeah, but before I start, I will explain two main things, because in the last several years, the topic of climate and climate change is the interest and the number of speakers and the webinars and books and publications and comments are exponentially grow up, and it's very complicated to summarize and to extract the most important and the most essential trends, facts, knowledge, and so forth. And because I am speaking with the different audiences, sometimes I'll start in with the basic knowledge, because I understood from my long-term research and from my long-term journey in these topics, what I'm talking about, that most people, in reality, most people knows these words like climate change, but they don't understand in detail which technologies are emitted the most, which countries are emitted the most, and why the important to understand that the annual emission and cumulative emissions are very different things. So that is why I need to start from the historical overview and I'll give you a little bit basic knowledge. And then I will speak about the mainstream concept. I call it the mainstream CO2 concept. You never heard this word, like the mainstream CO2 concept, because this is the only concept we are talking about. All speakers in the world are talking about climate change through the prism of CO2 concept. But for me, this concept is a mainstream, but not the only important. You have to know and you have to be focused on. So that is why. And then at the end, I will give you, I will present you another, I call it alternative concept of climate regulation. It's not a concept of climate change, but through this concept, you will understand that there is another explanation of the roots of a present climate change. And then I will show you the historical overview for the last 200 years at least, and I will give you the forecast for the next 100 years, or maybe the thousands of years, unfortunately, in some cases, using our 4Waves approach. And as I said at the beginning of my series of webinars, for me, this understanding that countries are in 4 different stages of their evolutionary development, and from in a different stages in the terms of mega transition, or the great transition, what we are calling it, from agrarian era to the modern urban industrialized, and they're in different stages. And I will show you why the world in the 20th century, during the 20th century, how these these trends changed and why the 4Waves approach is so promising that you could understand much better all these trends and all this data. Maybe you understand now only in general, but you need to understand it in detail. Using this 4-wave approach, I will show you that the world, unfortunately, still doesn't reach the peak of emissions. And in the next several decades, at least, we will see the growth of these emissions. First of all, from the third and fourth wave countries, like I showed the same trends in my previous lectures about demographic trends, about diet transition, about energy transition, and in all these topics, the general picture is the same. And one more comment, that there are a lot of data, and unfortunately not, I tried to build my own, like, very exact data for every point of this topic. Like, for example, how much greenhouse gases the world emits this year or in 2019. And you couldn't find the one figure or the one data. You will find 3, 4, 5 different data. That is why if you disagree with some of the data from my explanation, you need to understand that different agencies and different think tanks have a different methodology to calculate to this data. So, and that's I'm using the data from the right sources, but there is a huge spread in this data. And understanding this, we could go further. And I will give you the very brief historical overview of the topic of climate change, because it started not like the topic of climate change, it started, and for at least 1 century, it was like the typical scientific research of several scientists who were interested in greenhouse effect. They didn't think about cooling or warming the climate. They didn't think about the climate at all. They like made the research in a field of different kind of gases, the atmosphere, the other fields. And one of them was Fourier, very like famous physicist, and he discovered this greenhouse effect. And the main understanding what we have now, that in the Earth atmosphere consists from 3 main gases. 78% is nitrogen, 21% is oxygen, and 0.9% or almost 1%, but this is the last percent, that is important, 0.9% is argon, and the other 1.1% are all other gases. And inside these gases are several gases which have this greenhouse effect. Later, the Tyndall demonstrated that CO2 or carbon dioxide has this greenhouse effect. After that, we understood better and better that these greenhouse gases in the atmosphere are very important for stabilizing the Earth's temperature, or the air temperature at Earth, and stabilizing the climate and stabilizing the season changes and everything. What we understood, that the Earth, that in the atmosphere there is the teeny shell or teeny like membrane around the Earth, and this membrane is transparent for the sun sunlight, sun photons, which are coming from a sun and bring the energy to the Earth surface, to the oceans and land. Then they heat or warm up a little bit the Earth surface, and then the Earth's surface, starting like a radiator, emit the heating photons. And these heating photons, if there is no this membrane in the atmosphere, these heating photons will go out and in the space, and that's it. And the temperature at Earth should be, in this case, -15 by Celsius, the average temperature in the Earth. But we have +13 or +14. It's not very important because of this greenhouse effect. Some heating photons which emits from the Earth, from the oceans and from the land, goes to the atmosphere, but then they are captured by greenhouse gases. And another basic knowledge, there are 4 main greenhouse gases we are talking about, and they have a different so-called greenhouse warming potential. The CO2 gas capture, the 1 molecule of CO2 gas capture 1 molecule of this photon, heating photon, but the molecule of methane, this is the second largest greenhouse gas, catch like 28 heating photons. And another greenhouse, nitrous oxide, capture 300 photons of heat. And the F gases, of the molecules of so-called F gases, capture about 20,000 photons, the heating photons. So that means that despite the concentration of CO2 and methane and nitrogen oxide and F gases are very different, and CO2 concentration is the highest, and F gases are very small concentration in the atmosphere, but the warming effect is crucially different. And then in the 20th century, there was the very important scientist Calendar who discovered, or who firstly made this statement in the 1930s, that that rising the concentration of CO2 in the Earth's atmosphere could lead to global warming. So, and nobody paid any attention to this statement. And in 1958, there was an important event in Hawaii Island, close to the Mauna Loa volcanic. There was created the observatory, and James Killing, he became the famous, and we know this Killing curve. He started the experimental measure of the CO2 concentration in the atmosphere. And the first measure, what he did in 1958, showed that the concentration was about 315. And what we knew till this point, that the historical concentration for thousands of years, and even for hundreds of thousands of years before, was very stable and fluctuated around 280 ppm. This is parts per millions. This 1 part of CO2 per million parts of air. That is why the concentration of CO2 in the atmosphere is 1.0, like 4004. So that means that the partials of 1%, and but it was 280 for centuries before. And now, during this the beginning of the 20th century, we reach now more than 400 ppm. And for example, F gases has a ppb parts per billions. So the concentration is like 100 times less, but nevertheless, it's the warming potential much bigger. So even in 19, and James Killing did the first publication after that, and he announced that, okay, the concentration is higher than the historically it was for centuries before. But again, nobody paid any attention to this. And even in 1970s, there was a big discussions between two different approaches. Will we see the cooling the Earth because of raising the concentration of greenhouse gases or warming? And only in 1980s, the concept of global warming became the mainstream. So you see that it was like 100 years of scientific exercises. And then starting 1980s, I was like 15 years old in this time. This concept became the mainstream and the world started to talk about global warming. And the 1989, the Intergovernmental Panel for Climate Change under the United Nations was established. And in 1992, there was a first global climate convention. And in 1997, the Kyoto Protocol was set up and failed. In 2012, when the Kyoto Protocol finished, the world realized that the goal of the Kyoto Protocol was to cut or to decrease the average emission of greenhouse gases for 5% at least. But as a result of the Kyoto Protocol, the emissions increased for 40% or even for 60%. So it was unexpected for many, many people. And now we have, in 2015, we have a Paris Agreement. I will tell you about this. One of the most important thing you need to understand that not countries emit the greenhouse gases, because usually we know that we are hearing that, okay, China is the biggest emitter, or the United States are the second emitter, or something like this. But not the emitters, not the countries. The emitters are the technologies and the processes the world is using. And that is why it's important to understand that about 73% of global greenhouse gas emissions are coming from energy technologies or from burning hydrocarbons. The important understanding you have to have that we're burning coal and oil and natural gas to produce energy for different technologies and for different sectors. And another 25% of emissions we have from a food production or from agriculture sector, including deforestation, but that's the important part of our explanation. And the energy what we are using, usually we could split into three sectors. The biggest one is industry. But when we are talking about industry, we have to understand that there are several different technologies in the industry and the different types of energy carrier what are using in this. So one industries are using the electricity. The electricity is producing in power plant, burning coal or natural gas. And the other industries, like for example, iron and steel melting, are using direct heating, like coal burning. For example, the world now is producing 1.8 billion tons of steel, using 1 billion tons of coking coal. And to produce this coking coal, the world is using 1.5 billion tons of a coal, add natural gas, and produce this coking coal. And during burning, and this coking coal is burning to give the 1000 degrees by Celsius of temperature for melting iron ore and produce steel. So that means that we could not replace easily this coking coal in a volume of 1 billion ton a year to produce steel. So, and there is another very important part of the industrial processes which are burning hydrocarbons is a cement production. And the world now is producing 4 billion tons of cement, and it's almost gives to the world about 4 billion, a little bit less, 3.5 billion tons of greenhouse gases emission. So we have to understand that the different technologies are using different kind of energy sources or energy carriers, and not only electricity. And as I explained to the previous webinar about energy, in a total primary energy balance, the electricity has only 20%, and another 80% the world has from burning oil and natural gas and coal, and using direct energy without electricity. And the next big sector is the transportation sector, and it's about 16%. It's responsible for about 16% of the greenhouse gases, and all kind of engines, all kind of transports, road transport, air, aviation, shipping, tractors and buses and trucks, they all are burning oil products like diesel, gasoline, and kerosene, and some others. So, and the last but not the least sector is buildings. The buildings consume electricity, and as I said, electricity is producing from in the power plants burning coal or natural gas. But in many countries, the buildings are heating using or burning the natural gas. The pipe goes to the house, and people use these furnaces to burn the gas and to heat the house, and even for cooking in industrialized countries using natural gas. So, and if you understand all these details, and for example, agriculture, another source of emission is agriculture. Agriculture mostly emit methane. As I said, methane is 28 times more aggressive or more has a more warming potential than CO2. And the methane is emitting from cattle and from rice fields, because rice fields are covered by water, and using fertilizers produce a lot of methane. And you need to understand that the different technologies emit different gases, and that is important knowledge to understand, could we fix the climate and how fast we could replace all the technologies, like the techno-optimists are talking to us. How fast could we replace all the technologies and all the processes which now are emitting greenhouse gases, and how fast we could do it. And I will tell you about this in the next webinar. This is the world today is emitting about 50 billion tons of greenhouse gases, including 37, or in 2019 it was 43 gigatons of CO2, and about 9 billion ton of methane, and about 3 billion ton of nitrous oxide, and several million tons of F gases. And they are not in these statistics, but nevertheless, the F gases will be very important in the 20th century. This is more complicated graphs, which sectors emit which gases and how much. And I like to look at this. And as I explained to you, there are several, the most important emitters on the side of technologies and the processes the world are using now, and different gases, what these technologies emit. And the interesting thing is that everybody now knows that the concentration, the CO2 concentration in the atmosphere grew up from 280 to 410 ppm, but in 2019. But if we take into account all greenhouse gases, including methane and so on, the concentration of these greenhouse gases now in the atmosphere is close to 500, not to 400, to 500. And many researchers made the statements that like 600 ppm is the ultimate, like, impossible point to reach, because after that we will see the climate catastrophe. But as I will show you later, it's very possible, unfortunately. And another interesting aspect of a emission of greenhouses is so-called like land use and land use change, including deforestation. Because the interesting thing is that in the 20th century, in many countries in the tropical zone, like Brazil, Argentina, Congo, and the countries around the Congo River Basin and Indonesia, they are started to destroy forests in a very fast pace. But in CO2 concept, the forests looks like trees, separate trees, and each tree could absorb several kilograms or several tons of CO2 from the atmosphere for photosynthesis process. So the absorbing CO2 is natural for oceans and for forests and for soil. And if we cut trees, that means that we not emit CO2 like directly, but we destroy the ability of the forest to suck or to absorb the CO2 from the atmosphere. So the many countries from the not industrialized world, like for example Indonesia or Malaysia or Myanmar or like some others, looks like they are emitters of greenhouse gases, but not because they burn fossil fuels, but because they destroy forests. And in terms of a global balance, the interesting thing is that for warming effect, the more important is not the annual emission, but the cumulative emission starting the beginning of the era of industrializations, of the first industrial revolution. This calls like the cumulative carbon budget. And now we have the more and more detailed data. What is cumulative budget for every country and for every type of technologies and processes. And what we know that if we look at this cumulative budget, the land use and the deforestation is responsible maybe for 40% of total CO2 emissions. That's huge. That's really huge. And I will show you right now fast several graphs which will explain to you, which will help you to understand why the global emission in the 20th century accelerated very fast because we had in the different sectors and in the second wave countries, first of all, we had this acceleration of a mega transition. And here is the cement production graph. It started in the beginning, in the middle of 20th century, only developed countries from the first wave produced cement. But starting 1950, the second wave countries started to produce cement, and we see like a jump from 100 million ton to 4 billion ton. So China produced in 3 years, at the beginning of 2000, like in 2011, 2013, in 3 years, China produced more cement than the US during the whole 20th century. And now China produced, you see the acceleration. When China started to produce cement, it produced before in like 10 million tons. And now China produced 2.5 billion. 70% of the world's cement China produces. Same in the steel production. When China started this urbanization pace in 1980s, in 1990s, so it was 30 years ago, it was in a level of 0 of steel production. And now it produced 50%, so the equal the whole world is producing. If we looked at the number of cars, and the transportation sector is the second one, like a greenhouse gases emitter, you could see that the US, Australia, Japan, France, so all countries from the first wave, they were the main emitter in the 20th century because they became the car-driven countries. And the most cars from 1 billion in the year 2000 were from the first wave. And China now, at the beginning of this race for cars, and in the next 30 years, according to all kind of predictions, the China will buy, or the Chinese people will buy about 500 million cars. Now we have the whole passenger cars park in the world 1.3 billion. But in the next 30 years, from the second wave countries, and even from the third wave countries, we will get like 700 million more cars. And if we look at the number of cattle in the 20th century, in 1900, there were 500 million cattle, mostly in developed countries and in India. India is a historically like loved cattle. But in the middle of 20th century, there were 400 million. Now we have 1.5 billion cattle, and the cattle produce methane through the enteric fermentation process. It doesn't depend from the solar or wind technologies of batteries and so forth, because this is the cattle, and they are chewing and they are making this burn. And so this is the main methane resource in terms of emission. And according to the forecasts, we could see that in the next 30 or 50 years, the number of heads, of cattle heads, will increase, especially in the third wave countries in South Asia and in Africa. It will double. It could increase for another 500 million heads. And if you look at this, like sheep and goats and so forth, it will maybe double from the demand for meat in the third and fourth wave countries. Now, if you look at this fertilizers use, which started to use very widely only in the second half of the 20th century, the nitrogen and phosphorus. This is rocketed, and the nitrogen fertilizers are the main source of nitrous oxide emission. And we couldn't stop this process because we need more nitrogens for the next 50 years, as I explained in our webinar about dietary transition, about food, because in the third and fourth wave countries, which are now in the level of agrarian economies, it will be the huge jump. We could say that it will not be as huge as China demonstrated for the last 40 years, but even it will be, I don't know, 60% from China. That means that the world will double production of food, will double the consumption of steel, cement, and fertilizers, and so forth, so forth. You see, the China now is consuming like less than 1 billion, but close to 1 billion tons of steel. And we know that in South Asia and in 4 wave countries from sub-Saharan Africa, in the next 30 years, 2 billion people will go from the country village to new cities. So they will be urbanized, 2 billion people. That means that we could expect that the steel and cement production will be in this South Asia and Sub-Saharan Africa same like China now has, because there are another 2 billion people in South Asia and another 2 billion people in Sub-Saharan Africa. So we understand the trends and we understand how it goes. And as I said, you need to remember that starting 1800, for about 100 years or 150 years, I have the better graph I will show you. During the next 100 or 150 years, the first wave countries were the main emitters. So if you could see, it started from the Industrial Revolution, and the CO2 emission in United Kingdom rocketed. And even in 1900, it was in a high level, like 500 million tons. And if we looked at the balance by gases, which technologies emitted the most, you could see that the coal for 150 years, the coal in England was the main emitter, because the coal has been using for steel melting, has been using like firewood for heating and cooking in new cities and new houses. Then it started to be used like a carrier for new coal power plants, and the first power plants in England was coal-based. And then the oil started to be the significant emitter because of automatization of a country in the middle of 20th century. If you looked at the United States, you could see the same, but a little bit delayed picture, because the United States started the Industrial Revolution not at the beginning of 18th century, but at the end of 18 and the beginning maybe of 19. So, but then it rocketed. And if you look at the balance again, you will see that starting 1850 to 1950, the coal was the only and the main carrier which gave the energy and which fed all these technologies like steel production and power plants, electricity, and so forth. And then the oil became the biggest. But if we look at the second wave countries, they started to emit in the middle or in the second part of the 20th century, the Brazil, the Mexico, and then China came. And of course, in the terms of the volumes, the China jumped from 0 to 10 billion tons of greenhouse gases emission, annual emission. And this is, we could understand it much better if we look at these technologies, what China uses. You see that the coal was extremely important for China phenomenal growth, and the coal production or the coal consumption jumped from 77 million to 7 billion in 50 years. You see, the oil is not so important because Chinese still are in a very low level of automatization. The oil will be the next pollutant, or we'll talk in the next webinar about the chance to build 8 billion electric cars instead of oil EV, instead of ICE cars, internal combustion engine. And we could look at this, and as I said, that the cumulative budget is more important, the cumulative emissions. But if we looked at the world in 1950, so in the middle of 20th century, the 90% of cumulative emission was from the first wave countries, 90%. So they were the only pollutant. If we don't mention the deforestation in Brazil and Congo, it's a very specific topic. But now China is #1 annual emitter, and even cumulative, China now has about 15%. And if we look at the third wave countries, we will see the same dramatic dynamic, a little bit delayed, a little bit later, everything started, but we will see the same trajectory. And you could see like the Indonesia is like the last and the second wave, or the first and the third wave. It's not easy to say like exactly that in what wave it is, but you see the different path of a progress in terms of emission. It's not a progress, it's of course negative connotation, but the difference between Indonesia and Bangladesh, they are very equal in terms of population. But you see, the Bangladesh will go through the same path like Indonesia, like India, like China before, because all these countries, and if you take these countries from the second and third waves, you could see that they started to emit starting 1960. That's exactly the period of time when they started to make this mega transition. They started urbanization, they started diet transition, energy transition. They started to produce or to consume more steel, more cement, built more cities, and so forth, so forth. So I hope that now it's clear for you. But there is another important parameter, emissions per capita, and it was a huge discussion after the Kyoto Protocol and before the Paris Agreement, because all the countries from the third and fourth waves, which now emit in the level of 1 ton per capita, or 2 tons, or maximum 5 tons per capita. And if you take the countries from a first wave, like US, 20 or 15 tons per capita, Europe, 10 tons per capita, and they emitted for the last 200 years. That's the obvious civilizational conflict. The countries that from the third and fourth wave, they are struggling with the first wave countries, and they say, you could not give us a permission to use all these technologies what you used for your progress. We need to urbanize our growing population. We need to feed this population using the nitrogen or phosphorus fertilizers. We need more tractors based on diesel, not on somehow on a very promising hydrogen or electric technologies. And so we need it right now. And this very obvious conflict between these countries. And if we look at the cumulative emission for the last 250 years, you see that the leader is of course the Europe, but Asia now is #1, but only because for the last 50 years, the Asia made a huge progress. But if we take the first wave countries, we could see, I made a small math, we could see that 66%, till now, 66% of cumulative emissions are from the first wave countries. Still, Asia now has about 20% of share in cumulative emission, but this share will increase for sure. And the third and fourth wave countries, because we are talking about 4 billion people in the next 50 years, of course, we need to expect that from this region, we will see the growing economic growth and pollution growth. And this is like different kind of demonstrations, the share of different countries and different regions. And a few words about the carbon budget. And the carbon budget is according to the science, the carbon budget is the maximum greenhouse gas emission what we could afford if we want to achieve the goal 2 degrees warming by the end of this century. And if we have this parameter 2 degrees, and that we understand like for sure that, because we understand annual emission for the next like 10 and even 20 years, we understand that we will consume this total budget by 2049, so by 2050. That means that without any chances, without any miracle events or something, by 2050, the world will overpass this carbon budget, which is crucial for warming not more than 2 degrees. And what we know that according to the Paris Agreement, all these countries' pledges lead us to plus 3.6 degrees per Celsius, not 2. And there's another important picture you have to understand, that human emission is a part of the global cycle of carbon, methane, and the different gases. And before we started to emit, the humans started to emit, the carbon cycle was huge. 700 billion tons of CO2, or 200 billion tons of carbon, pure carbon. This is 3.6 coefficient to convert carbon to CO2, is emitted annually by plants, soils, and oceans, and are absorbing annually. And we emit now only about 12 billion tons, and 200 billions is a natural cycle. So we emit about 5% only. And for many years, people are discussing, okay, if we emit only 5%, it couldn't be so crucial. But unfortunately, what the scientists explain, this about 50%, roughly, it's not exact, but roughly 50% of this emission, of this human emission, are accumulating in the atmosphere, and they live in the atmosphere for many years, and sometimes for centuries. Different gases have a different lifespan. And this accumulation is crucial, because this accumulation increase, we emitted for the last 250 years more than 2 trillion tons of greenhouse gases. So this is huge, because this added to the existing concentration of greenhouse gases, and they change the global balance. And this is like important understanding you have to have, that even if we emit only 5%, but for the global stability at the Earth, it's enough to destroy it. And now I will give you some, and one of there are a lot of negative consequences what we expect from climate change. Now we understand, okay, we couldn't change the trajectory of our development. We are talking about the green transition, energy transition, and everything else. And as I said, the next webinar I will try to give you my understanding using our 4Waves concept. And of course, there is this important argument from the people like Greta Thunberg or the other activists. Because they explain that on 1% of the richest people emit like about 300 times more than the average people in the Earth, because they are flying, they are owning like ships, like yachts, and they eat more meat and so forth, so on. But I don't like to participate in this kind of political discussions. I am trying to find the right solution for this, for the 21st century. Because the main question for me is not who is guilty, and as I said, you could say the China is guilty, like the biggest pollutant, or maybe the Europe is guilty because it started first and it has like 30% in cumulative emission. But the question is not who is guilty now. The question is what we should do. And there is a huge difference between what we should do and what we can do. And I will explain you in the next webinar, but this is the important part of this discussion. And the important discussion is about sea level rise, and there are some catastrophic predictions, and some of them are like less catastrophic, some of them are more catastrophic. And for sure, for the next like 50 years at least, these discussions and this catastrophic prediction and this explanation will follow us and will follow the youth generation, because we could not change fast, even if we take this 50-year horizon for the next 50 years, we couldn't change the trajectory very fast. And there are a lot of scientists who are trying to find the best scenario how we could change this trajectory, because you see, according to the existing trajectory, by the end of 21st century, we could see more than 4 degrees by Celsius. And even with the pledge, they say we see now more than 3 degrees by Celsius. And some scientists like make a statement that this is total climate catastrophe. But the climate catastrophe is not an event, it's the process. This climate catastrophe could develop for the next 3 or 4 or 5 centuries. And we could not understand that we are in the catastrophe. This is the much bigger process, much more huge trend that our 80 years lifespan, like species. And there are a lot of modelists who are trying to predict, okay, how fast we need to go to a zero emission if we start to decrease this emission later. So if we start in 2020, okay, it will easy, but we couldn't do it in 2030, in 2050, and so this is the exercises for modelists, but they're not realistic for us. And now I will give you I will present you the alternative concept. It's not a CO2 concept of roots of climate change, and this concept could give us the totally different strategic tool for solving the problem with the climate and with many other aspects of our development. Even in a CO2 concept, mainstream concept, there are two main reasons for climate change, and it's obvious. Nobody discussed with this. The human emissions of greenhouse gases and deforestation. And what we know that for the last 300 years of industrial revolution, the number of trees, or the area covered by forests in Earth shrinks from 60 million square kilometers to 39 or to 40. So it's shrink for 30%. And 20% of these shrinks happen in the 20th century in the tropical zone. But if we take the more longer time period, like 500 years ago or 1,000 years ago, we had not we, but 80 million square kilometers of land was covered by forests. So then we had 60 million square kilometers before the industrialization started, and now we have 40. So the land area covered by forests shrink 2 times for the last 1,000 years. And because it started very fast in a tropical zone in Amazon basin in Congo and Indonesia, this, according to the concept of this biotic regulation, what this concept was created by 2 Russian physicists, theoretical physicists, or the smartest of the scientists, Viktor Gorshkov and Anastasia Makareva. I know these people for from 2010, so 10 years this year. And they spent totally, they spent 60 years of scientific efforts to develop this concept. And according to their concept, the main role what forests play at the Earth is the forests, according to this concept, are the super computer. So this is the biggest, not artificial but natural intellect what we could imagine, because it's much more complicated than all our supercomputers now. And the most crucial role for the climate regulation and even the water cycle, global water cycle regulations, plays 5 main forest areas. And this is the map of 4,000 years ago, how the land was covered by forests. And you see, and if we look at the 300 years ago, you see that the China and India is out of forests, and Africa has significantly less forests, and Canada and Eurasia and Europe was green, and now it's not green. So this is really significant change we have for the last centuries. And according to this concept, the forests in these 5 zones are playing the crucial role for cooling the surface of the Earth. Because in the vegetation period, the forests are working it's a very primitive explanation, but believe me, this is much more scientifically difficult explanation under this, but I'm trying to explain you the main idea. In these 5 zones, in Siberia, Canada, Amazon, Congo, and Indonesia, these 5 biggest forests of the Earth, they're working like cooling machines. They're pumping the heating air to the atmosphere, and therefore they cool the air around. But when they pumping it, they create the low pressure zone. And in this low pressure zone, the humid air from the oceans are going we call this flying rivers. It's going because it's going in the level of 1 or 2 kilometers up. This humid air is coming inside the continents from the oceans. And that is how the cooling air from the oceans is coming inside the continent and cooling the air in the continent. So, and this happened in the vegetation period, because it's a summer for the forests, and the forest push the warming air to the atmosphere and bring the cooling air inside the continent. So this is the huge thermodynamic machines in the 5 different regions in the Earth. And it worked well, but when we destroy forests in the 50% of our area, what it was before, now it worked 50%, or now it worked 50% worse. And it could not cooling the Earth as effective as it was before for centuries. So this is the main idea. And if we take this idea into account, we could understand that why this concept is so important for me, for 2 main reasons. If this concept is right, it doesn't matter, will we change our internal combustion oil engines and we'll see it into the electric vehicles? Will we go from coal-fired power plants to solar and wind? We will not fix the climate. Because if there is the problem that the cooling of the Earth is crucially depend from the area covered by trees and from the effective working of these forests, like these biotic pumps. We couldn't change the situation. And the second, if this concept is true, the solution for climate is much easier and much different than everything what we are hearing now from the techno thinking world about the energy transition and changing the technologies and developing new technologies, investing billions of dollars into the technologies and so forth. Because the solution is not simple, but it looks like much simpler. We need to increase the forest covered area of a land at least for 30%, better for 50%, but at least for 30%. This equal for about 1 trillion trees. And if we increase the forest area for 1 trillion trees, it could reverse the warming effect. And we will not see the global warming further. Of course, this is not the very fast solution, because the trees could start to work like this biotic pump only maybe in 30, maybe in 50 years. But nevertheless, this strategic solution is so important that I am sure that we need to do it anyway, without any discussions, in parallel with all other activity in the sphere of technologies, innovations, investing, and so forth. Because if we start now, in 30 years, the forest, what we will help to restore, will start to work like a biotic pumps. And the important thinking of this concept is that the tree is not equal to forest, or the group of trees are not the forest, because the forest is the live organism. This is a huge difference between the planting trees or seeding trees and the self-creating forests, which started from a very early stage, from a soil bacteria, from a first plants, from a grass, then bushes, then the first trees, like this special, because this is there is the special genomic program in every zone, in every continent, which tree could grow in which period of time, and how we could help to increase the forest area by 1 trillion trees, not to plant them, unfortunately. We need to close the huge areas of land in North America, in South America, in Eurasia, in Africa, and to close and to say that this is the area where people could not enter. No tourists, no travels, no buses, no no invasions of no economic activity. So, and if we could protect these huge areas, the forest will self-restore. And in 30, 50 years, the situation will be very different. So that's maybe our last part of explanation. Yeah.
Alexander, thank you. So can I shortly summarize and maybe I'm a little bit emotional, but it's look like all trends what you just shared with us exactly shows there are no chance to decrease CO2 emissions and all other gases. There are no any trend in this graph which shares or at least give a hope it will be decreased. There are only growth, and is it true or not? Is it right conclusion or not?
That is right conclusion, shortly speaking. But in the next webinar, I will try to discuss all these so-called solutions like solar, wind, batteries, Tesla, electric vehicles, some fertilizer substitutes, some cooling substitutes, and I will show that there is a huge misunderstanding and huge populism. What we are listening from 90% of all kind of speakers, presenters, and so forth. You see, remember, before the Kyoto, like when the Kyoto Protocol was signed, there were hundreds of politicians who signed it with that they were sure that we will decrease the emission by 5% in 15 years. They were sure, but then they disappeared because this is the election cycle, and nobody in 2012 who signed this agreement could say, okay, we signed it, but we didn't realize that it's impossible. Because that is why I'm proud that I'm non-partisan researcher. I am not the politician. I don't need to like make some claims like we need to zero the emission by 2050. Okay, we need, but we can't. And you need to be realistic. You need to have the strong education. You need to understand all these technologies, processes, and you could see. And if you are, you could see the trajectory, and you could see that okay, it's not enough. And after that, maybe you will start to ask you the main question I asked myself for the last 10 years. But maybe the climate change is not the biggest problem, and maybe focusing on climate change is the wrong focus for the 21st century, because the climate is one of the obvious results of our progress. This is a progress for sure, that 4 billion people now jump from agrarian era to industrialized urban. This is a progress for them. 3 billion people are from existing are wanted to make this jump. This is a progress for them. And another 4 billion people plus to the existing population will, yeah, we're sure they will want the same. We couldn't stop this transition, and we need to change the focus of discussion.